Hello everybody, in this video we are going to talk about pseudocode and flowcharts, which as you can see is number 3 in the program development cycle. So if you haven't seen the program development cycle video yet, I would suggest watching that first and then come here. If you have watched that, you'll remember that this is still the planning out phase. So number 4 being write the code out means that this isn't actually officially writing the code. And so what do we mean by unofficially writing the code? Let's take a look. Let's look at pseudocode first, because I think that's what people would understand the easiest. Basically, what you're doing is you're trying to write out a program without using a language, or should I say more succinctly, a programming language. But in the same way, you can develop that algorithm, which, if you remember, is the basis of all programming. You can write an algorithm out essentially in terms of very plain English or whatever you want to write it with. So I have a little example here where all we're doing is taking something and putting it out to the screen. If you think about it, that's essentially the golden rule that we talked about in the program development cycle. So first you create a variable, and if you want to, put your hand over the parentheses, because that is not pseudocode. I'm trying to make a point with that. So you create a variable, and in this case we're going to call it x. Then we let the user take and put something in for x, and then we print x to the screen. So input, output, processing. Golden rule right there. Now, what's in the parentheses is actually how you might do this in C#. So in other words, you're going to declare a variable x, you're going to set x equal to something. In this case, it's probably going to be a text box. And then you are going to change a label based on what the person put in from that text box. So pretty simple program, and it's pretty easy to lay out. Now, for most people, to write a program like this, you wouldn't even have to go to pseudocode. But this is just to demonstrate how to use pseudocode, because when you get into larger ones, you're going to want to think them out. But before we go to a larger one, let's take a look at what flowcharts are. So this is, or these are flowcharts. And to kind of better understand, let's think of these in terms of writing a program or just programming in general. Well, remember when we said we had to have an input, process, and an output? Those are the first two boxes you have. So whenever you use an input, you use a symbol I call it the parallelogram. You can call it whatever you like at this point. This box is going to be used for both input and output. Process, so when you're saying something equal to something else, you're doing some mechanic underneath the code. So in other words, the user can't see it. That's usually going to be called a process. Now, there's other things that also the user isn't going to be privy to. Input and output is not it, because they'll be able to put the input and they'll be able to read the output. But a process means usually filling a memory address in terms of a PC. But what happens if you have to compare two memory addresses? So in other words, is x less than 5? Well, that would take you to a decision. And the decision, as you can see up there, is a diamond. Then you have stop, start. This is pretty self-explanatory. Every program has to stop somewhere, and everyone has to start somewhere. You can also write parts of a program using flowcharts. So in other words, if you just want to do one subprogram of your program, you can use that stop start as well. So where it begins, where that subprogram begins, and where it ends. Connectors, this is if you run out of space. So let's say you make a flowchart and it's so big that you hit the bottom of the page. So you're going to use a connector to show that it isn't over and that it's going to continue somewhere else. If it's the dot or the one on the left, the circle, that means you're going to go up and look somewhere else on the page for that dot. If it's the thing that I call a home plate, I forget what you actually call this piece, but that means it's going to go to the next page. Lastly, a call is essentially calling out to a subprogram. So it's very normal to kind of make a bunch of subprograms and then have a main program called out to those subprograms. That call just says, okay, it's kind of like a connector, but in this case, instead of going to a continuation of thought, it's going to a subcontained little thing that you can reference whenever you want to. The lines of connection are not actually something that's going on in the PC or with our programming. This just tries to show the flow. So if you start somewhere, you end somewhere, and therefore you should have an arrow. So at this point, let me get out of the presentation and let's do some work inside my PowerPoint slide as we see it. So let's take the last one that we did, the example from last time. Create a variable x, get user input for x, print x to the screen. Well, believe it or not, that first statement, create variable x, you don't necessarily have to represent in Flowchart. That's one of the nice things about doing something in a flowchart versus pseudocode is you can kind of leave stuff up because the flowchart tends to be just purely logical. So let's go ahead and do it anyway. So I'm going to say, in this case, I'd have to use a process. So I'm going to take this and put it over here, and you could say something to the effect of, what do we say, string x. And that is a little too large. Actually, let me pull that out. Flowcharts you can do by hand. I like them. If I ever have you do one for homework, you can scan a hand drawing in. That's perfectly fine. The nice thing about PowerPoint is actually all these symbols are here. So if you click and go down to Flowchart, you'll see a whole bunch of these guys here. Most of these we won't use, but so we'll use probably most of the ones you can find right here on the top level. Okay, so let's go ahead and go with the string x, and then if we want to go back real quick, we'll say x is equal to some input text. So because there's actually two pieces here. There's the actual input text and then setting it equal to. So what I would probably do, and I'm just doing a control click to here, this is going to get the input. And we're going to want to save this as input x. So that's one piece. But to keep this safe, let's go ahead and grab another one of these. Oops. We are going to do a text box here and call this x is equal to some input dot text. And right away, what I'm finding here is that I am not actually doing this correctly, because really the input is not x, it's some input, right? So let's double click into this and hit some, not text. And let's straighten this out. I have a feeling we're going to have to switch to a smaller font on the next one when we get to the larger ones, but there we go. We will do this for now. And that makes a little bit more sense. And then finally, we're going to output. And like I said before, they should share the same shape. So let's go ahead and click on this and pull this guy down. And it's you're going to write or output, whatever you want to say. I like to say write X. Now, are we done? No. We have a stop and a start we have to put into. So let's go ahead and grab two of these. And we can merely just write start and stop. And you can put begin or end or whatever you want to do, whatever you want to say. I'm fine with that. So now this is our entire program that we've written out. But we do need the lines of flow. So let's go ahead and show which direction it's going into. I tend to like the see a more solid arrowhead, as you can see down here. But if you're going to do something quick and dirty, nothing wrong with doing this. And we finally finished our first flowchart. So you know where it goes, where it starts, where it begins, and it's easy to read. Now there's two reasons why you want to make a flowchart. One is for yourself to plot it out. The other is to demonstrate, because many times you're going to be asked to show how you're going to do something. And it's very easy to read these. I remember when I was going for my thesis, my advisor didn't have an understanding of what I was doing. So I ended up just writing him out a flowchart in order to kind of make him understand how I was going to go about achieving this information. Or in this case, it's kind of a program that read other programs. So and then he got it, and then it made sense, and then we went on with it. So you have these kind of two different uses for them. The other thing, as I'll say, is sometimes you see these start and stops. Oops, and I put start at the bottom. Let's change it to stop right away. Start and stop sometimes look more like an ellipse. That's fine. It doesn't have to be perfect. It doesn't have to be these rounded edges. Just make sure it's distinct from a box and it's distinct from a connector. Okay, let's try to do one tough one, and then we'll let you out of here. So now in this case, what I'd like to do is do something where you write your name 5 times. Okay, so there's 2 ways we could do it. We could just do it explicitly, like literally have 5 output boxes with your name, right? In fact, let's actually make it simpler so we don't have to use user input. Write name 5 times. So the word name 5 times. So again, you could do this with just using 5 parallelograms, or we can make this program a little smarter and use a decision. And this would allow us to do a couple more boxes. So I am going to be a little bit lazy, and I'm going to grab all these. And I'm going to dump them all here. Hopefully they all come with me. Okay, that way I can keep my lines, and I can keep my start and stop. And generally you're going to use this. So what's the first thing you're going to do? Well, you have to create a counter. So I'm going to go into this guy, and I'm going to say n is equal to 0, because I'm going to count from n from 1 to 5, right? And then in the next one, I actually have to make it count up. So moving these guys down, move these guys down a little bit. And actually, maybe we should move everything to the right, because we're going to run out of space, which is good, believe it or not, because then we're going to get to use our connector. So I have to create another process where n is equal to 1. Or actually, n is equal to n plus 1. Now, what does this do? Well, in computers or programming languages, equations are not like in math. So if you said n is equal to n plus 1, you could subtract n from both sides and get 0 is equal to 1. That's not what we mean here. What we mean here is that everything on that right-hand side of the equation forces the left-hand side of the equation. Let me give you the demonstration here. Right now, n is equal to 0. So you take 0 and plug it into the n on the right. That n on the right now is 0, so it's 0 plus 1. And that means the new n is equal to 1, now no longer 0. It's forcing what's happening on the right-hand side into the left-hand side. And that's why you'll always see a single variable here. You'll never see like n plus 1 on the left. Because essentially what we're saying is we're redefining n to be equal to 0 plus 1. And so that's so far so good. I like it. Let's go ahead and put it in. I'll use a line of continuity there. And I'm going to change this, though, to print name. And since it fits, I'm going to shrink it down a little bit. That's fine. It gives us some space. But the problem is that now it's printed name only once. We want to use this counter to the best of our abilities. So let's do that. But the way to do that is through a decision. And this is the first thing that we haven't used yet. So this will be the first time we use a decision. So there's the decision. I'm going to do a copy of it. And I'm going to put it right here. Move it right here. And generally these things are a lot bigger. So let's make him a little bit larger because basically it asks the question. What am I comparing, or what am I going to have to make a decision upon? And in this case, I am going to say n is less than or equal to 5. And I want to, since it's flowchart, it's not that big of a deal to use a big n and a little n, but a lot of programming languages are case sensitive. So a lot of times, so what I would suggest doing here is always keeping, if you're using a capital N, keep with a capital N. If you're using a lowercase, go with the lowercase. Okay, so now we have this, and what does it actually mean? What this is saying is, if n is less than or equal to 5, do one thing. If it isn't, do the next. Well, what are those things that we have to do? Well, we want to write it 5 times, right? So if it's less than 5, then we want to write it again, because it's only written this name once. So let's go ahead and create something that says, I'm not going to get this to curve right, but that's okay. We'll keep it going. And one more. That's not very good at all. Let's move this down here. So what it says is if n is less than 5, go back to here and add it again. So now it's instead of saying n is equal to 0 plus 1, and now it's going to be equal to n is equal to 1 plus 1, which is going to make it 2. The question becomes, though, is how does it know to do this versus something else? And what we're going to do here is say, if this is true. So put it somewhere here. Actually, you know what? I like it this way. I'm going to make it much smaller font and then make sure it goes right here. So if it's true, do this. And let's keep our lines of continuity here. If it's false, so in other words, let's say it comes up here and this is 5, prints 5, that means then that we've printed our name 5 times, then we can stop. So if it's equal to 5, we say, actually you could just get lazy here, and I'm going to do that. False. Okay, so now and some of you might be confused at this point, so let's go ahead and look at this left-hand table here. And let's delete a couple of these things too while we're here. So we're going to start off and we're going to track how many times the name has been printed and what n is at that time. So it starts off at 0, right? And then it goes down and it adds 1 to 0 to get 1. And then it's going to print the name right after that. So I'm going to say name. And in fact, it might even be better off to put it like this. And we'll explain that a little bit more later. Name could be a variable, or name can be the actual word name. In this case, we're using the actual word name. Fortunately, it screwed up my parallelogram, so let's do that. There we go. So now it's printed that. It comes to this decision. It says, well, 1, we put n here, or 1 here. It says 1 is less than 5. Well, that's true. Let's go up here, and this is now 1 plus 1, which equals 2. So now n is equal to 2. Then it comes down here. We get another name. Goes through it again. 2 is less than 5, so then we go to 3. Name. And we come down and 3 is less than 5, so 4. Name. And then 4 is less than 5, comes back up to here, it goes 5. Name. Prints out name again. And then 5 is equal to 5. That's true, right? So it actually comes up and does a 6 name. But that's a problem, right? Because we only wanted to print this out 5 times. So 1, 2, 3, 4, 5, 6. So we thought we could stop at when it equals 5, and that's true. We should have stopped when it equals 5. But what we have to do is redefine that decision in order to do it correctly. So let's go into here and merely change this. Change this to just less than 5. So when it hits 4, it's going to come up, change n to 5, and we're going to print this name, and then we will not get this last writing of name, because when after print's name here, it's going to come down and say 5 is less than 5. No, that's false. Okay, we're done. Stop. And I often tell my students who take me, go ahead and make that table or whatever, keep track of that, because you can always test out a flowchart. And I know a lot of people make flowcharts and then never test them out, but when you test them out, you can figure out where your logic's wrong. And once you understand where it's wrong, then you know you start understanding what is right. And then that makes a huge difference in how you make your flowcharts, and then a huge difference in how you make your actual code when it comes to programming. There is some software out there that will help you make flowcharts. As you can see, Microsoft PowerPoint does it, so does Word. But one I suggest, and in fact, I'm going to drop another piece in here, and I'm going to say *C Raptor. So I'm going to have you see Raptor, a website where they have something called Raptor, which helps you not only make flowcharts, but it actually lets you test them when you're done. So you can actually hit a button that says start, and it will run through your program and show you your output, which is really nice. In fact, it even has a converter, so it actually can take it and spit it out in terms of different programming languages. if I have time one day, we'll use it on these videos, and then you can see the benefit of it. But if we don't, go ahead and check it out on your own. Okay, this wraps it up for flowcharts and pseudocode. The next step is, I think we're going to do is show you what form sketches are.